Hello all, I Dr. Nidhi Sharma welcome you again for the corrosion science part 2. In this part, I am going to discuss about the factors affecting the rate of corrosion. This is very important topic of this chapter because number of factors are going to affect the rate of corrosion. Basically, we will concentrate on nature of metal and nature of environment. So one by one we are going to discuss it. Nature of metal. So the first is the position of metal in galvanic series. This decides the corrosion rate. If suppose a metal is present very high, means at a very higher position in the galvanic series, then it will undergo corrosion when it is in contact of the metal which is lower in the series. So or in other words we can say the extent of corrosion depends on the electrode potential. If the oxidation electrode potential of metal is high, then it will undergo corrosion rapidly. If the oxidation potential of metal is low, then the corrosion rate will be less. So, the metal which is highly placed, which is having the higher oxidation potential, or if we explain it in terms of reduction potential, then lower reduction potential, then that is going to work as anode and the corrosion will take place. So, nature of metal is highly responsible for the rate of corrosion. Then second is the hydrogen over voltage. This factor affects the rate of corrosion only in acidic medium. In acidic medium, the electrochemical corrosion occur by hydrogen evolution mechanism, and on anode the corrosion occur. So the voltage or potential at which the hydrogen gas is liberated at cathode is known as the decomposition potential. So at this potential, the hydrogen gas is in equilibrium with hydrogen ion. So this potential can be theoretically calculated. But experimentally it is observed that the actual evolution of hydrogen gas at cathode doesn't occur at this voltage or potential but require a higher potential. The reason being because at the surface there is an accumulation of hydrogen gas. So due to the accumulation of hydrogen gas, for the further corrosion you need the more potential to remove that hydrogen gas from the surface. So that's why the higher potential is needed. So this is because dissolving of anode occur at calculated voltage. The formation of hydrogen gas from hydrogen ion is slow and requires some additional voltage. This is why you need the higher potential. So as you can see in the example, it is inversely proportional to the rate of corrosion. Higher hydrogen voltage, oxygen 0.76, the slower the rate of corrosion. But if we add the few drops of copper sulfate, it accelerates the corrosion due to the reduction of hydrogen voltage. Earlier it was 0.76, then this 0.34. So the rate of corrosion will increase. Then third is the purity of metal. The purity of metal is highly responsible for the rate of corrosion. Higher the purity of metal, lower the rate of corrosion. The reason being, if suppose there is a presence of impurity of metal, impurity in the metal, then the impurity is going to work as cathode or anode. Then in that case, due to the heterogeneous solution, there will be a corrosion. So pure metal resists corrosion while impurities in metal form a local galvanic cell and result in the corrosion of metal. So for alloys, the system is a homogeneous solid solution, has no local action and no corrosion. Then the fourth part is the relative area of anode and cathode. This is very important. When two different metals are in contact of each other, the corrosion of anodic part is directly proportional to the ratio of areas of cathode part and the anode part. So if the ratio of cathodic area to anodic area is more, then the corrosion is greater. Means if cathode is bigger and anode is smaller, the area of anode is smaller and the area of cathode is bigger, the rate of corrosion is faster. And if it is reverse, means if the cathodic area is small, so as the cathodic area is small, so the demand of electrons will be less. So the demand of electrons will be less, so automatically the rate of corrosion will be less. Then next is the physical state of metal. The rate of corrosion is influenced by the physical state. Like the metals such as grain size, orientation of crystal stress, these all are responsible. The smaller the grain size of the metal or alloy, the greater will be the solubility, hence greater will be the corrosion. If suppose there is an area under stress, even in pure metal, it tends to form the anode and cathode, as already it has been explained. The stress result in the formation of cathode and anode area. So this is due to the fact, actually the reason being, metal at the boundaries have electrode potential different from those with the metals atoms which are present in the grain. So this leads to the formation of anode and cathode, and the grain boundary may be considered to be stress. So due to the formation of anode and cathode, the corrosion will occur. And then sixth factor is the nature of oxide film. So this has been already explained, like an oxide film formed by the reaction between metal and oxygen. If the oxide film is porous, oxygen can diffuse into it and the more corrosion will occur. Also, if the volume of oxide is more than the volume of metal, least corrosion and no further corrosion. So the nature of metal is very much responsible for the corrosion. Like volatile oxide formed by the metal, corrosion rate is very high. If oxide forming porous film, then it is a non-protective layer, the corrosion rate will be high. But if it is a non-porous and protective film, initially the corrosion of the surface will be occur, then later the corrosion will be stopped. So in this way, the nature of oxide film is highly responsible for the corrosion. Now the second factor is the nature of environment. So the first factor is the temperature. The rate of chemical reaction and the rate of diffusion increases with the temperature. As the corrosion involves several chemical reactions. Hence, in general, if the temperature increases, the chemical reaction increases and the corrosion increases. So thus the corrosion changes or increases with the rise in the environmental temperature. The second factor is humidity. The corrosion of metal is very fast in humid atmosphere than in dry atmosphere because the moisture acts as solvent and for atmospheric gases. So like oxygen, carbon dioxide and some salt. So this produces an electrolyte and which is required for the corrosion cell. So moisture also reacts with the metal oxide causes electrochemical corrosion. Metal like magnesium, aluminium, zinc, chromium, iron, these all get corroded due to the presence of moisture in the atmosphere, even in the absence of oxygen. Then the third is the pH value. pH value is highly responsible for the corrosion. Acidic media are more corrosive than alkaline and neutral medium. First, very important point. So the corrosion of iron is slow above pH 5 and in absence of oxygen. The presence of oxygen increases the rate of corrosion. And most of the metals are readily attacked by acid but are resistant to alkalis. So the corrosive tendency of such metals can be reduced by increasing their pH. By maintaining the pH, we can control it. But again, like zinc corrode minimum at pH 11. But higher than pH 11, it corrodes faster. At pH 5.5, aluminum corrodes minimum. Above 5.5, corrosion is faster. So the nature of rate of corrosion of different metal is different. Then fourth one is the nature of ions present. Presence of anions like silicate in the medium leads to the formation of insoluble reaction product which forms as a barrier and inhibits the further corrosion. But whereas if suppose chloride is present, the medium destroys the protective and passive surface film and exposing the metal surface for the fresh corrosion. So it means, or in simple language we can say like chloride ion and the ions which are very smaller in size can easily destroy the metal, but the metals which are bigger in size like silicate can act as a barrier. Then next is the conductance of the corroding medium. The conductance of corroding medium is highly responsible for that. In case corrosion underground or submerged structure, the conductance of the medium play important role. So that the clay, minimized, mineralized soil is more conductive than sandy soil and therefore the corrosion rate is high in clay soil. So the rate of corrosion is high in highly conducting medium. This is very important. Then the formation of oxygen concentration cell. So if two different portion of the same metal are exposed to two different aeration and receive different amount of oxygen, then the oxygen concentration cell is formed. And such differential aeration leads to the corrosion. Thus, highly oxygenated metal surface are less immune to the and it will undergo the corrosion. So this is, as you can see, this is oxygen concentration cell. Here iron, where the oxygen is more, is going to work as cathode. Here iron, which is in low oxygen, it is going to work as anode. So here the less corrosion, and here it will increase the rate of corrosion. So in this way, it is going to affect the rate of corrosion. So thank you all for watching this video. Thank you.